आप हाथ उठा के बताइए, पद्म श्री का मतलब समझते हैं आप लोग? हाईएस्ट सिविलियन अवार्ड हिंदुस्तान के 140 करोड़ लोगों में से 200-300 लोगों को मिला अभी तक। इसका मतलब क्या है कि दे आर द ट्रू लीडर्स, जिनको हम सब ने मिलकर रिकॉग्नाइज किया थ्रू आवर प्राइम मिनिस्टर एंड द प्रेसिडेंट ऑफ इंडिया। तो मुझे लगता है कि दे नीड एन स्टैंडिंग ओवेशन फ्रॉम ऑल ऑफ यू, एंड दैट विल बी आवर ट्रिब्यूट टू आवर स्टेट। थैंक यू वेरी मच।
At the outset, I would like to thank Jecrc for giving me an opportunity to share with you how India started its space program and where we are today. Dr. Amit Agarwal, Dr. Amratan, Dr. Victor, and all of you students who have gathered here. Indeed, probably all of you, when you look out to the sky at night, you'll be many times wondering whatever you are seeing in space, the stars, the planets, etc., at what distance they are and whether it's possible for any of us to go there. Maybe some people will be wondering whether I want to go and land on moon, etc. But sure, as human beings started evolving on this planet Earth, in the initial times, he was looking at the sun actually comes in the east, then sets, and then you have night. And those days there are no light pollution. You would have been seeing very beautiful sky and lot of stars, planetary systems, etc. Then gradually he started observing them and realized that there are some repetitive patterns. And by looking at that periodicity, he was able to get into how there are planetary bodies or star systems that existed. And in the initial times, you are also familiar that he could actually move around only with his own legs. And then gradually, when he wanted to cover larger distances, etc., he started looking at what he can do. He started domesticating animals, then horse riding, and then carts or chariots, and then later cycles, scooters, and then steam engine. So gradually he built up vehicles for movement. In the same way, if you are also familiar, physical labor, what he was doing, to minimize that, he started building heavy equipment. That means cranes, so that he can reduce the physical labor he is doing. And then after taking care of the physical activity, he started looking at how the intellectual activity can be done outside the human body. So started with calculators or mechanical computers, then calculators, and then later computers. Today it has reached artificial intelligence based gadgets, where probably whatever gadget you have in your hand, mobile, has a capability which is much more than the first computer that was built. First computer occupied almost this entire space what you are seeing, and that much space it was occupying. But then today, equivalent capability is there in a small device. So in the same way, man conquered land, ocean, airspace, and then today he is looking at space. Space itself we consider it as the fourth frontier. That means going beyond Earth, and then going beyond Earth, looking at Earth itself to see what is happening, and also looking beyond Earth, all these things. So probably many of you are familiar, in 1957, a very significant event occurred, which made a huge difference to the human beings on planet Earth. Anybody can tell me what that event was? 1957. Anybody can tell what the event was? First object put into space, Sputnik, by Russians. So at that time, Americans and Russians were competing with each other to demonstrate who is more powerful, who is mightier, because the Cold War between America and Russia ensured that they were trying to demonstrate one superiority over the others. Quickly, Russians put a man in space First lady in space, Valentina Tereshkova, and then Americans started feeling what is happening, Russia is going ahead of us, we need to do something. So they decided we will put a man on moon. So then they went for their man moon program and they succeeded in putting Neil Armstrong onto the moon. And then while all this was happening, we had in our country a very great visionary scientist, Dr. Vikram Sarabhai, who was looking at, we know we got our independence in 1947, so 57 is just 10 years into independence, and we had a lot of problems to solve. There are a lot of hungry people, development has to happen. We have been actually dominated by colonial rulers for hundreds of years. So there was huge problems. But then, like today you are familiar with what is called disruptive technology. Going to space was a disruptive technology. So Dr. Sarabhai looked at how we can make use of this ability to go into space, put satellites in orbit, how we can use it for our country's benefit. So at that time, if you want to communicate with one person, suppose you are in Jaipur and you wanted to talk to somebody in Bangalore or in a remote place in Assam, etc., it would not have been possible the way you are doing today. Today all you need to do is pick up your gadget, dial a number, you will get instantaneously connected. Such a thing did not exist at that time. So what Dr. Sarabhai was looking at is, how can we make use of space, put a satellite in what is called a geostationary orbit. That means, we know for example today, moon takes how many days to go around the earth? Anybody can tell me? How much time moon takes to go around the earth? Okay, around 28 days? 28. Okay. So, as the height of the satellite beyond Earth keeps changing, the time it takes for it to go around the Earth changes. For example, near Earth orbit, what we call 900 to 1000 kilometers, it takes about 100 minutes. That means in 1.5 hours it can go around Earth. Now Moon, which is at a distance of 3.8 lakh kilometers, takes almost 28 days. So that means in between these two, there must be one height where it takes exactly 24 hours. So that particular height is called a geostationary orbit height, and it's around 36,000 kilometers. Advantage is, we all know that Earth takes 24 hours to go around its own axis. Now if the satellite also takes 24 hours to go around Earth, it becomes stationary with respect to a human being or a person on Earth. So it's like many of you, when you travel in trains or two vehicles moving at same speed, they appear stationary to you. So this satellite, which is at 36,000 kilometers, can look at 1/3 of the globe simultaneously. For example, when you want to cover a large area, what you will do, you will go to the highest point. If you climb on a mountain or a tower, you can see a large area. Same way, if you are on the satellite at 36,000 kilometers, 1/3 of the globe is visible to you, so you can do line of sight communication. So Dr. Sarabhai visualized that India can get advantage of this space technology by bringing in connectivity across the country by using such satellites. So what he did, he convinced Americans that they should allow us to borrow their satellite for 1 year. And it was moved over to the Indian longitude. And like what you see today, direct to home television, a small set-top box in your house and a small antenna helps you see a program on your TV. But in 1975, ISRO conducted experiment of bringing direct to home community television for 1 year, and in 2,400 remote villages of our country, broadcasting was demonstrated, and the government it became clear that if we get into space technology, we can quickly build this broadcasting capability and connectivity and improve communication across the country. And another thing you also will remember, that we have these super cyclones when they come. We have tens of thousands of people losing their lives. But by looking to Earth from space, you can see how clouds are moving from one place to another. And by looking at the cloud pattern, you can get cloud motion vectors and also predict when a cyclone will come and hit a particular coastal area. We have 7,500 kilometer long coastline. So using satellite observation, it is possible to tell cyclone when it comes and hits a particular coastal region. In the earlier decades, India, the situation used to be tens of thousands of people used to lose their lives because we were not knowing when the cyclone will hit that particular region, and because of the fury of wind, then lots of people used to lose their lives. But today, with satellite technology, we can tell days in advance, and disaster relief agencies can evacuate the people there and save their lives. So what I was trying to tell you is, so Dr. Sarabhai looked at use of space technology. So how did he achieve what he wanted? So first he convinced his friends that we need to conduct some experiments in this place using sounding rockets in the form of kits. Many of you are familiar today, Atal Tinkering Lab, all these kits are there. Using those kits, you understand how a system works. So in the same way, Dr. Sarabhai convinced his friends across the globe, brought sounding rockets in the form of kit, got it assembled, and using that conducted upper atmospheric research, because India has a unique place, geomagnetic equator near Kumbh, and using that he convinced. And for doing that, one more very interesting story is there. See, the church at Tumba, that was a place where the first sounding rockets were assembled and launched. For doing that, in that beach, he had to convince the fishermen, you allow us to conduct these experiment, rocket firing and all that, so you have to vacate this place for us to do the experiment. For that, he had to convince the fishermen using the help of priests, telling the fishermen, you vacate this place so that we can do this experiment, and one day in future the country will benefit. Just as though to prove this point, what happened, today a small battery operated gadget is fitted to the boat of the fisherman. This gadget talks to our NAVIC satellite. Using the signal sent from the NAVIC satellite, like a GPS, it can identify where it is in the ocean. That means its latitude and longitude is known. Similarly, we have a mechanism where by looking at the color of the ocean from the satellites we are operating, probably just a few days back, whatever satellite is launched, OceanSat, is one such repeat mission, where in 11 different bands, you look at the color of the ocean, through that identify the chlorophyll, and from chlorophyll, the food chain of the fish, and then tell where in the ocean fish school is available. So this is a latitude, it's called prospective fishing zone information. So this information is transmitted as a message from NAVIC. So the gadget in the boat of the fisherman receives this information. Now when the fisherman is in the ocean, few tens of kilometers away from the coast, no terrestrial tower can reach the mobile because it is beyond the coverage of the terrestrial tower. But this mobile has a Bluetooth or Wi-Fi connectivity. So the gadget communicates with the mobile. In an app using the mobile, in a video compass mode, it points to the fisherman where he has to go for fishing. So with that, he knows exactly where he gets the fish. So with this alone, you can imagine, and there is in the app, in his mother tongue, it tells him about any weather vagaries that could occur in the coming days. That means if the weather is going to be unfavorable, it alerts him. And also, if he is touching the international boundary, sometimes you would have seen in the papers that some fisherman is caught by our neighboring countries because they have violated or they have crossed their water boundary. So this mobile now tells him in his mother tongue that you are crossing the boundary, be careful. So now you can see here an individual who does not know reading or writing. but he is getting the advantage of using the most advanced technology of rocket, satellite, instruments, telling him where to go for fishing. It assures him his fishing fish catch and his livelihood. So that is the beauty of the space technology what Dr. Sarabhai initiated, and over the last many decades what ISRO has been doing continuously is use the technology accessible to us, but what is not available, build on our own. Today we have our own launcher which can put satellites into orbit, and you also know that not only our satellites, but we have put more than 400 satellites of 34 countries across the globe using our PSLV. And you also know that in one launch of PSLV, we were able to put 104 satellites into orbit, and at that point in time, it was a world record. Later, of course, like any records are going to be broken, Elon Musk put more than 130 satellites, and today the record stands in Elon Musk's name. But if in future, if some of you want to make sure that India goes ahead and puts more satellites into orbit, the opportunity is available. You also know that private enterprise even in our country is moving ahead and building capabilities. You saw the example of the sky roads, putting a satellite like a sounding rocket going up to 100 kilometers and then come back to us. And in that they also had put a number of small satellites of Space Kids and others. And today there is also another company which is setting up a facility in Shri A.S. so that for future the more and more the Indian entrepreneurs can do this space business. So today what ISRO has done is started working in the early 70s, 69, 63 onwards in fact, and then over a matter of 4 to 5 decades built a capability of having our own satellites in geostationary orbit. Not only that, we also demonstrated that the observation what we are doing helps us navigation, communication, direct to home television, then earth observation, telling the government about crop yield, what is the crop assessment this year, how much wheat is going to be grown, cotton, groundnut, rice, etc. All this. More than that, you can also look at what is happening beyond the boundary. So a host of such applications are there, and communication. Apart from all this, we also showed that when a person looks at sky from ground, you know that the atmosphere comes in between. And on some cloudy days, you cannot see anything. And even on other days, atmosphere actually attenuates a lot of signals that come from the sun or stars or other celestial objects. And if you can go outside the atmosphere, you can make very good observation and highly sensitive information you can pick up. So what India did is started conducting space science experiments, and few examples you will see also in the exhibition. In 2008 when India launched its Chandrayaan mission, though man had already landed on moon, a large number of probes were there on the moon surface. The credit for this particular satellite is it discovered the presence of water molecules and OH molecules, and for the first time demonstrated that moon has water, and that credit came to India, Chandrayaan 1. Similarly, when Mars mission was done, just to give you a glimpse of the kind of challenge that is there in this mission, on 2013 November 5th, when the satellite was launched, the task cut out for that was this object should travel 60 crore kilometers or 600 million kilometers for over a period of 10 months. After traveling that much distance, at the end of that period, on 24th of September 2014, morning 7:30 a.m. to that second, you imagine in this space a cube of 50 kilometers. That means a cube which has a side of 50 kilometers. If this satellite is not inside that cube, it would not have been possible for us to make that satellite get captured in the Martian atmosphere or Martian gravitational influence and perform its orbit. And what all forces can change the direction? You know, sunlight when it falls on any object produces a radiation pressure. How much pressure it produces is infinitesimally small, but still that force over a period of 10 months is sufficient to take it away from that cube of 50 kilometers, and it would have been elsewhere if we were not able to control it and then redirect its orientation. And another thing is how to communicate with this object which is so far away. Even if everything is working, if the satellite is not looking at Earth, it's only 2 degrees angle. If the direction is away by 2 degrees, if everything is functioning in the satellite, we cannot do anything. We cannot communicate with it, etc. So those were the challenges. But in spite of all those challenges, India demonstrated to the world that we can do this kind of a very critical activity in a time and cost which is very different. Another very interesting thing probably you will also be happy to know is when we built our AstroSat, in that today you are hearing about James Webb telescope which has got a huge mirror, etc. etc. But still, this AstroSat has a telescope which operates in a particular wavelength called far ultraviolet. Ultraviolet is a region where our eye cannot see. Our eye can see between 400 to 700 nanometers. So below 400 nanometers is where the ultraviolet is. And in this particular wavelength, we have a telescope which has an angular resolution 3 times better than the best in the world today. So because of that, the Indian research community has been able to get data of a region in space which is almost 9.8 billion light years away, and they got this signal for the first time ahead of any other research team, and they are able to come out with some new observations and modeling inputs, etc. Why I am telling you this is, though many times we may feel the advanced countries have moved ahead, they have got technology which is far beyond what we have got, but in science and technology, it is never too late. You can always find something which has not been found so far. And for that, what we need to do is, we need to make sure that the capabilities that we have, each one of you is a highly evolved robot, a robot of a capability which does not exist outside the human life form. You have got a perception system or a computer system inside you which is far better than any computer we can build today. For example, a human being takes only between 20 to 40 watts of energy for all its function. Today, even if we were to build a remotely similar functioning system, we would require gigawatts of power, and for that also we have to make use of a huge space, etc. Though science and technology is continuously growing, its capability is still very limited, and what each one of you have is much more. Only thing is, you need to know that you have this capability and you can take advantage of that and build. I'll just give 2 examples before I close. See, for example, there was a person, a born blind individual. If you give him a problem, multiply a 10 digit by 10 digit number, you just orally tell him the 10 digits and tell him multiply with another 10 digits. Addition, subtraction, multiplication, division. He will instantly give the answer to you. That is the kind of capability he has built. Similarly, if you look at a young girl who is going to touch 15 in a couple of years from now, who has already climbed 5 of the 7 topmost places in the globe. There are 7 high points across the continent. She has already climbed 5 of them. Before she touches 15, she wants to reach even Mount Everest, the highest point. Now what it shows is, human being has tremendous capability depending on what he or she wants to do, and focusing on doing on that, they can achieve that. So this born blind person was thinking if Shakuntala Devi can be called as a walking computer. Some of you may not know this name, but if you Google, you will find out who Shakuntala Devi was and what were her capabilities. And she could actually do a lot of mathematical computations, etc. like a computer almost few decades back, even before current level of computing capabilities was there. So this person got the inspiration from that. He trained himself. Similarly, if you want to become a 100-meter runner, you will build your muscular strength and achieve. That means what you want to achieve, if you decide and start preparing for that, you can achieve anything you want. If ISRO has shown to the country that in spite of the limitations of resources, just to make you aware, what India has spent on space technology, right from its inception till today, if we add up all the money, it will be less than a fraction of 1 year's budget of NASA. With that, what has been achieved is basic. That means the capability that you have is so enormous. So if you make up your mind, if you keep your observation capability and then curiosity intact and keep asking questions and finding solutions, you can become great individuals who can solve problems of not only our country but also of the entire globe. Because today what is needed is more and more value-based approach to life, and all of you have the privilege of studying in very innovative and well-established education system where you have so many opportunities. Not many in our country have similar opportunities. So what you need to do is to make the best use of the opportunity you have, learn as many things as possible, and continue the process of learning, because today science and technology is moving at such a rapid pace. What was good a couple of years back becomes obsolete quickly. So what is needed is to learn the process of learning, not the content. Content is not that important, but learning the process of learning and then experience. These are the things that make the difference. Make the best use of the opportunity you have in seeing what has been done and how we can bring in a new life to this society, solve the problem. Today, if you look at one of the things that happens in science and technology is in solving a problem and in thinking that we have brought a great solution, many times we overdo it, and the consequences you are hearing, whether it is climate change or environmental impact, these are all the consequences of certain rapid changes that have occurred. But as we learn new problems and new impacts, we have to correct. I'll just give one example before I close my talk. See, way back in the 70s, when we had gone to Russia, we were taken to a place where a huge dam was built across the Volga River. Dam was being built to generate electricity using hydroelectric power. So we were shown that they were having this hydroelectric power. They also showed in that place a fish lift. In the dam, there was a lift, and what that lift was doing, it was catching the fish, taking photographs of that, and picking up from downstream and leaving it upstream. So we were wondering what's happening. In Russia, probably some of you are familiar, caviar is an export item, and they earn a lot of money using export of caviar. Caviar is nothing but fish egg, and this is coming out of a fish called Solomon, which swims thousands of miles upstream. From ocean, it goes to freshwater river joints and lays its egg. When the dam was constructed, the path of the fish got blocked, so it could not go to the freshwater joint and leave its egg. So as a result, the caviar production came down. So what fishermen started doing, they picked up the fish initially using baskets and started leaving it upstream. Then the government decided to put the lift and did that. That means when you do something, you are upsetting a natural process, and then that has impact. When you learned about that, you brought in the corrective action. Same way, Canadian birds, when the birds migrate to Siberia going across US, they were getting killed while sitting on the huge towers. The Americans decided for a particular period, few days in a year, they will shut down all their lights to enable the birds to move in their path without getting distraction. So same way today, you have to look at the problems we have created in our desire to provide better life conditions. Sometimes we have made many mistakes, but then it is for you to realize what those mistakes are and what corrective actions should be done. How will it happen? It will happen only when you start looking at what is happening around you. Keep that curiosity, and if you keep that curiosity and look for problem solving, you will achieve great success. So you make use of all the opportunity given to you. What you are going to see here is how over a period of 4 to 5 decades, India built this capability of space technology, and how in future Indian economy should get the advantage of technological capability that is built. What was available only in an organization should be available to the entire country. That is the way the country is going. So the events like this, where Jecrc is trying to make the next generation aware of what is happening, awareness is the key. And let me wish each one of you a great success in your life, in not only learning but also making sure the skills what you have acquired and the knowledge you have acquired is used for the benefit of the society and humanity in large. Thank you very much.